Hey guys, welcome to another video. In this video, I'll be taking you through on how I created an interactive shear force and bending moment diagram calculator, a web app calculator using AI. So basically what I wanted to do was take a problem from a standard textbook like vector mechanics for engineers, take a beam problem from that and then feed it into the AI and try to find out if we can create a calculator, a parametric calculator in which we can change the loads, we can change the section or not. How good does it perform? So I'll be using the Gemini Pro 3.1 model. So let's go ahead and do that. So this is the problem which we'll be taking, which is a overhanging beam, which is having a pinch support here and a roller support here. And there are two loads, 20 kilonewton, 40 kilonewton, A, B, C, D are the points. So this is the input which I'll be giving to the AI along with the prompt, and it will do the coding and it will create a web app for me. So let's see how it does that. So here is the prompt. Make a web application beam calculator to calculate and plot the shear force and bending moment diagram, and also calculate and plot bending stress, finding the point of maximum bending stress. The section of the beam is a rectangle. Make a sub calculator in which I can change the section height and width, and it recalculates, replots the bending stress. The beam configuration is as shown in the image. This is the earlier image which I'll be sharing with the AI. The load point and the end conditions are kept as fixed. So we want to fix those end conditions and load points, but we should be able to change the magnitude of the load and the section of the beam. So these two things which we can change, which it should be interactive, which we can change in the application. So let's go ahead and do this. So this is the Gemini app which I opened up in the web browser. So I've attached the image of the beam and I've copy pasted the prompt, and I'll be selecting the Pro model, which is the latest model from Gemini. It says advanced maths and code. So select that, go to tools and go to canvas, select canvas and then submit it. So here is the web app which Gemini has created. So 20 kilonewton here, 40 kilonewton here, A, B, C, D. Does it match with the image? Yes, it does. 2.5, 3, 2. Reactions are also given, 46 and 14. And this is the bending moment diagram. 26 kilonewton, 20 kilonewton at the bottom. So if you just change this load, is changing the diagram. So yes, it is interactive, and the rectangular cross section is 100 by 200. So if you change this, is it changing the stress? Yes, it is changing the stress. So this is a good output. It is creating a very interactive shear force and bending moment diagram with the sliders in which I can change the load, which is really good. But important is accuracy, whether it is accurate, whether the calculations being done at the back end are correct or not, that we need to check. And of course, this is something which we always need to check with AI. We cannot always depend on it for the calculations, at least not yet. So next step is to check the calculations with the textbook calculations, whether it's matching or not. So here is the solution from the textbook taken in this screen grab. So in the textbook, the solution shows the shear force and the bending moment, and you can see the spacing. So A, B, C, D is shown over here. This line is for A, this line is for B, this line is for C, this line is for D. And the values are also shown. So shear force is 26 kilonewton over here, plus 26 kilonewton, here minus 20 kilonewton, here minus 14 kilonewton. So let's check whether it's correct or not. So yes, minus 14 kilonewton here, minus 20 kilonewton here, and plus 26 kilonewton here from 2.5 to 5 meters. Bending moment, minus 50 over here. Does it match? Yes. Minus plus 28. Yes, it matches, plus 28. So shear force and bending moment diagrams are matching. Also check the reactions. So the reactions are 46 kilonewton and 14 kilonewton as shown over here. 46 kilonewton and 14 kilonewton upwards. Check with the reactions in the textbook. So this is a solution in the textbook, only calculating the shear force and the bending moment diagram. So you can see that the reactions over here are correct, 46 and 14 kilonewton, which matches with that in the web app calculator. So this is the backend calculation which goes on as shown over here. So basically the AI was able to create that interactive beam and stress calculator how I wanted it. I checked the output along with the textbook problem and it was matching, which means that it is accurate enough to at least start creating basic designs of such calculators. For advanced, more complex calculations, you have to be careful and you have to always keep checking with the equivalent textbook problems or with hand calculations. So proceed with caution, but yes, AI calculators are getting better and better, and the Gemini Pro is a great model for creating such web app calculators and modifying it however you want it to modify it based on the parameters which you want to change. So here I've changed the load. I've kept it as a slider, load A and load at A, load at C, and also the width and height of the section. We can also make a new prompt with a different type of section. We can give images of the section and we can say which parameters we want to change, and it will create that. But again, we need to proceed with caution. We need to always keep checking that whatever the output is the AI is giving, whether it's meaningful or not. That also has to be checked. So yes, it is a very useful tool for design engineers who are designing machine components. It can help in creating such calculators which can basically make the job easier for the design engineer in selecting and designing components. But of course, we need to keep in mind that these AI can make mistakes, at least for now. It is maturing. As time goes by, it will become better and better. We always need to keep that thought in mind when we are making such calculations, especially for mission critical applications where safety can be a concern. So we have to be very careful and cross check.